Welcome. This is the second part video of Unit 3, Activity 2. Consider the equation x squared minus 3x plus 10 equals 0. Let's confirm this equation has no real solutions by graphing it. And let's go ahead and clear all. So there's clear all. And I'm going to graph y equals x squared minus 3x plus 10. Oh, where'd it go? There it is. It's just kind of up high. So we've confirmed that it does not touch the x-axis. That tells us that there are no real solutions. And quickly, before I move on to the next parts, I want to elaborate a bit further. And to do so, I need more space. So I'm going to white this one out for now. And basically, I want to show you how we can tell there are no solutions algebraically. So if you remember in the quadratic formula, x equals, and I'm going to write it all in black and trace the important parts over in red, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Well, here's the important part. So there are three possibilities. B squared minus 4ac is less than 0. B squared minus 4ac equals 0. And b squared minus 4ac is greater than 0. So in this first case, and let's call this case 1, we have complex solutions. So no real solutions. So you're going to have something of the form x equals a plus or minus bi. Those will be your solutions. If this part highlighted in red equals 0, then you have one real solution. So you're going to have x equals some number and nothing else. Now finally, this last case, which I'm running out of space for, so I'm going to scooch things around just a little bit. In this final case, we have two real solutions. And the third case is most of what you've seen up to this point. Today we started case 1, and then occasionally you'll see quadratics that only have one solution. That would look something like this. Y equals, say, x minus 1, and then this whole quantity squared. Let's look at the graph. If you notice, it only has one spot, one root, one spot where it touches the x-axis. But if I say subtract 3 from it, or 5, then suddenly I have two roots. So I changed it from a case 2 to a case 3 by just subtracting 3. Now I'm going to delete that since that's not what we're looking for. Hopefully this will come in handy as a tool to tell if a quadratic has solutions without having to graph it. Let's continue. Now we're going to use the quadratic formula to find the complex solutions to this equation. And the equation I mean is this one here. And let's use technology and round to 4 decimal places if needed. So x equals, let's see, a is equal to 1, b is equal to negative 3, not 3, and c is equal to 10. And I get that by looking at these coefficients. So this is 1, negative 3, 10. 1, negative 3, 10. And let's go ahead and fill this in. Negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 10. And all of this divided by 2 times 1. So negative 3 plus or minus in our square root, we'll end up with 9 minus 40 is negative 31 over 2. So I know this is negative 3 plus or minus an I times positive 31 over 2. And if you're missing what I did in this step, let me erase this. So I hope by now you've written this down because I'm going to get rid of this on the page. All right, so as an aside, what did I do on this step? If we have the square root of a times b, I can write this as the square root of a times the square root of b. So I wrote the square root of negative 31 as the square root of negative 1 times the square root of 31. The square root of negative 1 we know by definition is equal to I, so this is just I times the root of 31. And now what is the square root of 31? See, this rounds to, so x equals -3 plus or minus, and let's definitely stick to 4 decimal places, 5.5678 divided by 2. Oh, it looks like I forgot my I here. Let's not do that, or we might just forget that we have a complex solution here. So I have x equals 3 over 2 plus 5.5678 over 2i, and x equals 3 over 2 minus 5.5678i divided by 2. So 3 over 2 is 1/2, x equals 1.5 plus, now what is 5.5678 divided by 2? Well, that's about 2.7839i. And those are the two solutions rounded to 4 decimal places. Personally, I prefer exact solutions, so in future classes you might consider getting used to writing these solutions as -3 over 2 plus or minus root 31 over 2i. This would be the exact and preferred solution. These rounded solutions also acceptable. Let's continue. For problem 6, I'd like you to do this one independently. See if you can come up with the same solution I came up with, which is x equals 2 plus or minus 2i. So you should have 2 solutions and they are complex. So again, don't forget to check your work against these 2 solutions. I hope this video was helpful.